Hello, this is Ms. DB. In this video we are going to look at the linear inequalities worksheet. So we're basically going to graph linear inequalities. I have Desmos open on the left here. GeoGebra also works well, but you're going to be graphing a lot of linear inequalities, so you're going to want some method of doing that. So first of all, here's some information. When you have the line, like this is probably y equals x, when you graph an equation in a coordinate plane, you can use slope-intercept method to graph it, or you could use intercepts, or you could plot points. There's lots of different ways. But once you have the line, that's it, you're done. For an inequality, you're not done once you have the line. That's just the boundary line. And then you have to shade in either above or below the line, and you have to decide whether the line should be a dashed line, or we could call it dotted, or a solid line. So in the last assignment, the exploring linear inequalities, you looked at that and when you would use those different things. Here's a summary of what you should have learned doing that exploration. So you can look back here and make sure that you know which part to shade and what kind of line to make. If you are going to graph these by hand, you can, and the assignment has some graph paper attached to it. If you want to do that, then you have to make sure to make the boundary line correct, have the correct slope and the correct y-intercept, and then shade the correct way and make sure that your line is either dashed or solid. So you can also use technology to do these. Sketchpad doesn't work very well for inequalities. You can graph the boundary line, but it won't change the line to dashed or solid, and it won't shade for you, so you have to do that part by hand. If you use Desmos or GeoGebra, this is going to be a pretty easy assignment, except that you're going to have to attach your graphs. That'll be the most work. So to graph x is less than 20, you just go into your technology that you're going to use and type that inequality, and I'm going to, you would not want to attach this graph because it's all solid, shaded red. I need to see the boundary line, and I need to see that it's a dashed line and that I'm shading to the left of that line. So you can either take a screenshot of this and paste it in here. That's one option. I'll do that for this one. So I'm using the snip and sketch that's in Microsoft Office. So now I just draw around the part I want to include. You may want to include the inequality so that I can see that you typed in the correct thing. And then I will copy this, and then I will just paste it here after the inequality that it matches. It's going to take a minute because I'm making a video and it's probably going to have a little bit of a hard time. I can see that it's trying to do it, but it's not quite there yet. There it is. So it's huge, so I'll make it a little bit smaller, but not so small that when you turn it in, your teacher can't read it. I'm just going to put this down here so it's closer to it. So now I can see that, yep, you have correctly graphed x is less than 20. Let's do one that's not quite so straightforward. How about number 4? So in Desmos, move this over a little bit. In Desmos, you can use type exactly what you see. Actually, I'll do 5 because this one has a greater than or equal sign, and I'll show you where to find that. So I can type in 3x, number 5, 3x minus 4y, and then it's got a greater than or equal, which my keyboard doesn't have. But in Desmos, I don't know if you can see it, at the very bottom left there's a show keyboard or keypad, and one of the options there is the sign that I need, the greater than or equal. And then I can type 12. So if I look at this, you can, if you want, you can change the color of the shading. We certainly don't need to do that, but if you feel like it, you can in Desmos. Once you're happy with your graph, I see that it has a solid line and I shaded below. This one would be hard to tell if I shade above or below because it's not y by itself on the left side. I would have to pick a test point like 0, 0, see if it's true or false. So let's do 0, 0. 0 minus 0 is 0, but 0 is not greater than or equal to 12. That would be false, so that means I don't want to shade the part with the 0, 0. That's how you do it if you're doing this by hand. So instead of a screenshot for this one, I'm going to share the link. So share the graph, then it gives you this link, copy it, then come down here and paste it. Hit a space bar one time. Now it's a live link, and now I can just click on it after you turn it in. If you didn't click the space bar, I'd have to try to copy and paste it, and doing that from Blackboard is kind of tricky. So please hit the space bar one time and I will see your graph. Except that I put that in the wrong spot. This was number 5. There. And see, now it's not a live link. Now it is. Now I can click on it and it'll take me right to your graph. So you're going to do that for each one of these. Either do a screenshot or the link for each one. And then there is a few questions at the end that are a little bit more than just graphing these. So let's look at these. You might still be using Desmos to get your graph, but you have to do a little bit more work beforehand. Let's see. There's basically 3 of them. 12 is just changing your answer from... I'm trying to decide which one I should do. How about number 14? If a theater wants to take in at least $2,000 for a certain matinee, children's tickets cost $5 and adult tickets cost $10. If X represents the amount of adult tickets sold and Y represents the number of children's tickets, write an inequality describing the number of tickets that will allow the theater to meet their minimum take. So together they want $2,000. Every children's ticket costs $5, so that would be 5Y. Every adult ticket costs $10, so that would be 10X. If we add those together, they want to get, I just need a plus sign here, they want it to be at least 2,000 or greater. They'd be completely happy with getting like $3,000. So it should be greater than or equal to 2,000. The way I make greater than or equal is I just underline my inequality. There. That inequality now will represent how much money or how many tickets they need to sell in order to get greater than or equal to $2,000. Okay, if 100 children's tickets and 100 adult tickets have already been sold, what inequality describes how many more tickets of both types the theater needs to sell? Well, there's different ways to do this. You could find out how much they've already made with $100 each and then make a new inequality. That would be one way. Another way would be to try to change the original inequality that you wrote. But I think I'll just go ahead and figure out if I have 100 children's tickets, that's $500. And if I sold 100 adult tickets, that's $10 each, that's $1,000. So I've already sold 1,500. So that means that my new inequality, they only need to sell 500 more. Because they've sold 1,500, 2,000 minus 1,500 would only be 500. Make that be or equal to. And then that would be a new inequality. It doesn't say to solve it or anything. If the theater has only 300 seats, so only 100 are still available, what inequality describes the maximum number of additional tickets of both types the theater can sell? Okay, so we can't have more than 100 seats. So this has to fit, X and Y together has to be less than or equal to 100. I think that's all they're really asking for, is that together you can't have more, together with this. So it's like a system of inequalities, that both of these things would have to be true. We could graph this. It doesn't say that we have to graph it, but it might be an interesting problem to graph and see when both of those things could happen. So it has to be true that together they have to be less than or equal to 100 because there's only 100 seats left. And it also has to be true that they have to make greater than or equal to $500. Greater than or equal to 500. So we need to zoom out so that we can see where these two things are happening at the same time. So I'm going to unselect this for a second. So this was the seats less than 100. You could have so many children's seats, so many adult seats, like you could have 50 of each, of course. And then when I combine in this is the cost one, they have to get at least that much, so it's a greater than or equal. And when you put them together, the overlapping region, which we're going to do more in another quarter, when we look at systems of equations and systems of inequalities, but this region here represents, that's how many seats they have to have. The X was the children's tickets sold, and Y was the adult tickets sold. So you, for example, could not sell a whole bunch of children's seats and still make that much money if because there wouldn't be as much money made because the adult tickets cost more. So it's kind of interesting. All right, so let me know if you have any questions. Practice your technology, or if you want to graph by hand, that's an option too. Thanks a lot and have a great day.